Cool. Anyway, thanks so much for having me. I feel so thrilled to get to interact virtually and hopefully someday in person with all of y'all who are doing the really important work of farming in the city. I'm new to Georgia, and I'm so excited to kind of like get to know my neighbors here. It's a part of agriculture that I don't know. You're doing the most important work on earth to me, and I'm here for it. I'm excited to learn more about what you do as time goes on. But today I'm going to tell you a little bit about pollinators, and we've got an adorable squash flower here. You're gonna see a lot of like awesome squash footage, because that's my current study system that I'm examining right now across farms all over Georgia and South Carolina and North Carolina. So we'll dig into it. But before I got going, I was like, if you want to show your friends something really cool, and some of you have probably tried this before, if you've ever just like opened any squash blossom on a warm day afternoon, after the flowers have closed, you're pretty likely to find, even in a city, especially in a city, in fact, you're pretty likely to find some male squash bees sleeping inside. I have yet to understand this phenomenon, why the males like nap in the flowers, but it's one of the most adorable things that I've ever observed. And it's something that you can show your friends on any warm afternoon. It's really cool. But squash bees are those like smaller than honeybee things that you always find in the squash blossoms, and they do the most important work of pollination of most of your cucurbit crops. But of course, it's not just bees that pollinate. There are different flies that masquerade as bees. Here's one that's pretending to be a bumblebee, and another that's pretending to be like a yellow jacket or something. These are both flies that are hairy and can pollinate crops as well. And even birds and bats are important pollinators, although and butterflies, of course. But if you're a moth or a butterfly, those insects tend to be more closely specialized with the host plants that they pollinate. So for this, like, this is a tobacco flower, and you can see it has a really long corolla, which is like can you see my cursor? Hopefully, I think people can see it. It's a douchey word for this pollen tube. So bees so butterflies and moths have these incredibly long proboscis, which is a douchey word for tongue. So they unroll it, unfurl it, and stick it in the flower. And so flowers co-evolve with their pollinators with a really specific length of this corolla. And so that guarantees this extremely specialized relationship between them and their special pollinators. So a lot of the diversity in among flowers is due to these specialized relationships. However, among the crop species, it's mostly bees that do that work. You'll see relatively few of the crop flowers with this really long corolla, which is kind of a signal that it's pollinated by butterflies and moths. So like, since we're for the most part interested in, I assume lots of us are interested in food production. So I'm going to talk to you about the most common bees that we see in farming systems. So bees are the most important animals that are doing the work of crop pollination. But in animal pollination in general, including like bees and butterflies and bats and hummingbirds, is responsible for fertility of more than 85% of the flowering plants globally. So pollinators are key to having plants, and they're key to having life on Earth, essentially. And most importantly, they're key to 75% of the global food crops, like either depend on animal pollination or highly benefit from it. And most importantly, they're responsible for all the crops that are delicious. Like in this picture, all the delicious crops depend on animal pollination, except for some reason peaches are able to self pretty well. Although we think that they benefit from pollination as well. So I don't know that there's any delicious crop that wouldn't do a lot better with the help of pollinators. Moving the pollen from the male part of the flower to the female part of the flower so it can develop a fruit. And it may be like I was curious when I learned this for the first time, but a bunch of the most important crops that we think about, we assume that honeybees are kind of like the pinnacle of the workhorses as far as pollination goes. And they do a good job, and they're easy to manage, which is why they're they're so heavily depended on in a lot of systems. But there are a lot of crops that are pretty poorly pollinated by honeybees and depend really heavily on native bees. So you'll see here, like peppers and tomatoes are both, they're in the same crop family, the solanaceous crops, and the pollen on pepper and tomato flowers is electrostatic. So it's on the we call it a stamen where the pollen is on the flower, but the pollen only comes off the flower unless it experiences the buzz that only a bumblebee can make. So they've got this really precise wing beat frequency that releases the pollen like a rocket off of the flower. And that's what enables the bee to be able to collect it most effectively. So honeybees do a pretty bad job of pollinating peppers and tomatoes. So we want to like be sure that when we're excited about pollinators, we're thinking beyond honeybees and considering the important work that native bees do in our food crops. So the most common pollinators you'll find if you join us for the pollinator census, which I really hope that you do, are carpenter bees, which are like the enormous guys that are, I think they're probably the most common thing that you see. At least that's the most common thing that I see in our plots when we do pollinator surveys. Honeybees, of course, are probably pretty recognizable to you. And then the smaller eastern bumblebees, which are like probably about half the size of the giant carpenter bees. And of course, there's going to be like a big variety of other bees too. But the biggest ones you're going to see are these big three: carpenter bees, bumblebees, and honeybees. And this is a good figure that I borrowed from the Great Pollinator Census website. They kind of describe the carpenter bees as a semi truck and a pickup truck, as like in helping to distinguish their size. But another really easy way to distinguish a pollinator or a carpenter bee from a bumblebee, a regular bumblebee, they're both bombus, is by their butt. So the carpenter bees are enormous and they have no hair on their abdomen, so they're shiny. And that's a key way that I distinguish them. And also carpenter bees, like many of you might sort of revile them a little bit because they can do some damage to wood on the faces of houses, but they're also they're kind of like bullies among the pollinators, I would say. It's like a mixed blessing having bumblebees around. So they're really, really good at pollinating things like asters, like sunflowers, where all of the pollen is sitting on top of the plant and the nectar is easily accessible. But with something like blueberry, you can see these little holes in the blueberry flowers. Those are made by carpenter bees that are doing nectar robbing. So they're like it's easier for them to get to the nectar because rather than like putting their tongue into the delicate flower, they like go into the side and bite a hole in the corolla so that they can just get the nectar without doing the important work of collecting the pollen and moving it around. So it's like there are like costs and benefits to having these guys around, and I catch them red-handed all the time. So I spend like every spring I watch blueberry plants and like check to see if they're pollinating the flower correctly or if they're biting the bottom of it. So that's when I caught red-handed this spring. And another fun fact about carpenter bees, and actually many of the bees in general, the males are a lot smaller. So like ladies rule. And the males also have this like weird little yellow patch on their face. So if you might not have ever noticed it before, but if you're looking for it now, you'll see lots of these yellow patches. And that's a signal that it's a male. And so there's no bumblebee they're solitary species, so they don't have this instinct to defend their hive. They don't have this like social behavior. So you're really, really unlikely ever to be stung by any bumblebee unless it's like tremendously provoked. So if you like sit on it, or if you're smashing it with your hand, you might get stung, but it's like a desperate act of self-defense. And importantly, if it's a male bee that has no stinger at all, a stinger is a modified ovipositor. So it's like the egg deposit tube that that only females have. And so if you see a bee with this like yellow patch on its face, you can comfort everyone around you with the knowledge that it's a male and it can't do you any harm. And my students have this crazy party trick where they'll see the bee with the yellow patch on its face and they'll grab it by the wing out of the air and like frighten everyone around them. It's kind of incredible. So they're like, well, it can't hurt me. And so they'll just like pick it and then like pass it around like show and tell. It's really crazy. I don't know if we can recommend that from the University of Georgia. but it is possible if you correctly identify the males with the yellow patch on their faces. Anyway, another really common bee that does a lot of very important work as far as pollinating crops are sweat bees, and they come in like a huge variety of shapes and sizes, and particularly colors. My favorite one is this like crazy, I call it green halictid zebra butt. Halictidae is the name of the family. And so most of them are kind of shiny and have like fewer hairs, but many of them aren't. But all of them are pretty small. So on the Pollinator Census website, there's like a category for small bees, because it's really hard to identify those precisely without capturing them and like killing them and putting them under a microscope. So we bin them really conservatively when we do this census. But sweat bees, there are lots of them that are easily recognizable and quite adorable, if I say so myself. Here's another adorable bee that's my favorite, except it's not like, nope, it's not a bee. It's one of those like masquerading hoverflies. So this is a fly in the family Syrphidae. And if you're interested in distinguishing between bees and flies, most of the flies have a little bit less hair on their bodies. They're not as awesome at pollinating as bees are, but they're pretty good at pollinating actually. But the key ways to distinguish them, so flies and bees are actually like very, very distantly related, but flies only have 2 wings, while bees have 4 wings. And sometimes it's a little bit hard to tell, but they have 4 wings, and this hind wing is like kind of tucked under the main one. You can see that there are 2 if you look really closely. And bees always have, and all the Hymenoptera have, most of the Hymenoptera have elbowed antennae. So they've got antennae that go like this, they're jointed. Whereas the flies just have these like pathetic little nubby antennae that are like that. And so those are easy ways to distinguish them for the purpose of the census, and also for like I don't know, if you want to like impress your friends with really random weird information. But my favorite fun fact about hoverflies is that so it's a fly, so when they're babies they're technically maggots, and maggots don't have any legs and they don't have any mouth parts. I don't really know how they survive in general, but they're obviously very, very prolific. And a key special incredible thing about hoverfly larvae is that they're predaceous when they're babies. So they eat aphids. They're like aphid specialists. So this guy has no mouth parts, no chewing mouth parts, and no sucking mouth parts at all. Just like all they can do is kind of like vacuum the aphid into their body, but they somehow find a way to like destroy entire colonies of aphids without having any legs to be mobile with and without having a mouth to chew with. It's kind of incredible. I don't really know how to express my admiration for their incredible capacity. But if you can tell, they kind of like superficially resemble caterpillars, and I'm ashamed to admit that I've like confused them in my sampling before when I didn't have my search image clearly established for hoverfly larva. And so these are all examples of, these are the most common caterpillars you'll find on brassica crops. So you've got a diamondback moth, a cabbage looper, and this is the cabbage white butterfly larva. It's got kind of like a yellow stripe, and they've got a purple sheen sort of. But when I met my first syrphid larva, I like recorded it as a caterpillar because it looks suspiciously like the rest of them. And I'll never do it again, because they have one of them is a beneficial insect, and the other 3 are pests. So I don't want to mistake a pollinator and a predator for a caterpillar ever again. And so the thing that distinguishes caterpillars and fly larvae is that the caterpillars have legs. They have prolegs in the front, and then like actual 6 legs in the back end of them. And also they just like move completely differently. So a syrphid larva, a fly larva, because it has no legs, it kind of like shovels itself around in sort of like an undulating fashion. So if you see something that looks like suspiciously like a caterpillar, but maybe isn't, if you give it like a little poke, and if it walks, then it's going to be a caterpillar. But if it wiggles around in a awkward little way, it might be a predaceous hoverfly larva, which will grow up to be a pollinator, one of the most common. Other things that you might see on the pollinator plants as we do this census include a lot of the predatory bugs. Like most predators actually rely supplementally pretty heavily on nectar and pollen to keep them going in times of famine when there aren't tons of pests available. So here's a damsel bug that's impaling a caterpillar with its piercing sucking. It's got like a sword mouth. And big eye bugs are also really common on farms, and particularly in a city. And also a minute pirate bug, aureus. This is what it looks like when it's an immature baby. And when it's adult, it has like this checked appearance. You might also find tiny parasitoid wasps on your flowers if you look really close. They also rely on nectar and pollen, and these are beneficial insects that like ruin aphids by laying their babies inside, kind of like alien style. So this is a tiny wasp that's stinging a cabbage aphid, and then the baby wasp grows up inside the aphid and like bursts forth gloriously. Once it matures, it cuts a hole in the butt and leaves this like mummy carcass behind. If you've ever seen this like crispy golden thing on your plants in the garden, that's like a ruined aphid that's been killed by a parasitoid wasp. Parasitoid wasps also attack caterpillars. If you want to see a really incredible movie about that, I included a link here. I don't have time to dwell on it too much though, but they do the same thing. They lay their babies, but they lay hundreds of babies inside the caterpillar, and then they eat the caterpillar from the inside out, and then cut a hole in the caterpillar and spin their cocoon and pupate. They go through metamorphosis just like butterflies do, but they pupate on the outside of the caterpillar. And here's another one that is already, this is a cabbage white butterfly on a brassica, but they've cut the hole in the caterpillar, and they're using its dead carcass to kind of like shelter them from predatory insects in a big mass under its body. There's like all kinds of incredibly metal stuff among animals that you can find on flowers. You might also meet a green lacewing, which is a really crazy alien. And when they're larvae, they're predaceous too. They've got these like sickle mandibles, and they impale aphids and kind of like, they don't have chewing mouth parts exactly, but they hold the aphid over their head and just kind of like lap up their body juices. And they have really adorable eggs. If you've ever seen anything like this, it's really strange. But the mom lacewing puts their eggs up on top of a tiny thread stalk to protect them from predators on the leaf surface or on the stick here. Another animal that you might find lurking around flowers is a Hoverfly. This is another predator, and it's like a rather big fly, and it's got this constricted abdomen over here. Oh, have we only got 3 minutes left? They're distinguished by their incredible beards. Bobby, do we really only have 3 minutes left? I didn't realize what time it was. I just saw like a timer.
I believe we have till 8:30, but
oh, okay. I'm like, oh my goodness.
We're gonna check on that timer.
I won't be too long. I'm actually like I'm not too far from done. I wanted to leave time for questions and answers if people are curious about any of this stuff.
Yeah, definitely.
Anyway.
Well, let me just make a quick announcement.
Oh, sure.
We will post just a little backup Zoom link in the chat. If for some reason we do all get cut off here with this timer,
okay.
If everyone will go ahead and copy that link that we're about to post in the chat.
Oh yeah, let me get that.
Yeah, hold on one sec.
I was like, what does that mean? I tried not to take too long.
No, you're great. This is perfect.
Anyway, I'm gonna kind of like walk through some of the tips that we have for making farms hospitable and community gardens to beneficial insects and pollinators in particular. And so the key thing that they all need is food, shelter, and I call it love, but what I really mean by that is, I mean, you can express love in many ways, but one very key way to express love for beneficial insects is to minimize insecticide use to the ability that with as much as you're able to. Oh my gosh, my pets are having some sort of like weird game right now. Anyway, and so I'll share some resources with you for the different pieces of information we have about how to strategically do that on a farm or in a garden. And hedgerows is like a really important way that farmers that operate in rural acreage where the landscape is sort of like dominated by agricultural habitat. And there's a lot of information already out there for farms like that, but there's relatively little for urban farms. Oh no, I'm sad. I had a bunch of slides here that are in this not updated document. Anyway, oh man, I'm disappointed.
And Carmen, if you don't mind, I'm going to just make a quick announcement for everybody.
Oh, it's in the chat.
Yeah, there is a Zoom link in the chat. If y'all wouldn't mind, just go ahead and maybe copying and paste that somewhere convenient. In the event that we do get cut off here in just a few moments, if you wouldn't mind just joining us over on the next Zoom channel.
Beneficial insects. Oh, okay. And then, and moving on to thinking about the newest work on pollinators in the city. So this is kind of like this is a relatively new field, and most of the exciting stuff that we know about how to shape habitat in urban spaces that are unique to that are quite unique and distinct from rural areas is only a couple years old. So it's like it's a hot time to be in the city. And so the emerging knowledge that's come out so far, there are a couple different studies that have come out that have examined all the different kinds of habitats in a city, in an urban environment that a bee might enjoy. We've got like home lawns and turf and flowering plant and ornamental flowering plants and cemeteries and nature reserves and parks and roadsides and pavement. That doesn't seem like a likely place to find a pollinator. But what they found based on this preliminary information, well, it's a consistent pattern. Like 3 or 4 papers have found this, is that the community gardens that y'all manage in urban farms are like a hot spot of diversity among pollinators. So the plants that you grow in an urban farmstead are key resources for pollinators. And so you're going to be more likely to see like a great abundance and diversity of pollinators in a community garden. That's what they mean by allotment. You can see like the wheelbarrow. It's like a managed for agriculture sort of.
Wow.
And so you're creating the best place for pollinators in all of Atlanta. Should we give this person a second to? Great. Hi, everyone. Again. Anyway, it's kind of incredible though that that farms and garden spaces are these key resources in cities for pollinators and other beneficial insects, and more so even than nature reserves, because a lot of those are in various stages of restoration, and it's really hard to get that stuff right. So the floral resources that bees and butterflies really need to thrive are the most common in farm spaces. So you're doing really important work as far as crafting habitat for diversity in ecosystems in the city. And another pattern that's emerged, so I've provided a link to all the papers that I'm discussing here. So if you want to learn more about this project, this was a summary of 360 different sites across a whole bunch of cities. It was in England. And there's another study that focused on San Francisco, and they were searching for all of the kind of like environmental predictors of pollinator diversity and activity across urban farms. And the strongest pattern they found was that mulch cover was negatively associated with pollinator activity. And it's kind of like it's sort of reflective of the different kinds of habitats that are available to a bee in the city. So we're less likely to see bees in manicured lawns, and even in parks and nature reserves, and certainly on pavement. And it's because of their like total dependence on flowering plants for food and homes and stuff like that. And so in a really well manicured community garden, if it doesn't include floral resources intentionally planted for pollinators, you're going to be less likely to see them. So that's one thing to keep in mind. Although I know that like there's often a really high priority among community gardeners to make sure that you create a space that appears presentable so that you can get along with neighbors and stay out of trouble with city employees and stuff. So I I understand that, but it's also some incentive maybe to include some intentionally some beautiful pollinator attractive flowers in a community garden space as well. And if you're interested in doing that, the best repository that exists right now, as far as I know, is from the Xerces Society, and they have an incredible repository that's Southeast region focused. There's one in every region of the country, but they've curated just like a big collection of resources for managing habitats to promote pollination services. And one of these key resources is a plant list of native plants that thrive here in our region. And here, this is just a picture of the guide that they have, but I've provided a link to it here if you're interested in checking this out. But it's a list of common plants that you can find that can thrive in the state of Georgia, and it gives really precise information about what kinds of pollinators it attracts. So some of them are good for bees, and some of them are good for butterflies, but all of them are well adapted to this part of the country and can be incorporated in your garden plots. And also, finally, we're like behind the game a little bit as far as like developing like landscape ornamentals that are good at promoting pollinator activity. But like this is a presentation from the American Horticultural Society meeting given by my friend Jason and Bodhi. One of them is an entomologist and the other is in the horticulture department at UGA, but I provided a link to their presentation because this is unpublished data still. But what they've done for the past like 4 or 5 years is that they compared like 20 or 30 different landscape plants that are native to the Southeast in a side-by-side like comparison to see which ones provided the best resources to pollinators and which were most attractive to beneficial insects generally. And so they've made a list of the kind of like the top 5 and 10 annual and perennial plants that that can attract beneficial. About this, then both Jason and Bodhi are easy to get a hold of, and their contact information is linked in this. If you click on this hyperlink on this page, you can get to their e-poster, and they've made a really incredible video, kind of like a video version of their poster with like pollinator action shots on each of these flowers, and they're going to be really useful if you're interested in learning more about how to identify specific pollinators, because I can show you like what they look like with a macro photo, but the easiest way to develop that search image that's precise enough that includes like their size is to use something like a video. You can see them in real time on the flowers that they'll be looking at. But anyway, we've got like blanket flower, this helenium. They're all the awesome ones are asters and mints as far as like attracting the biggest variety of pollinators, and mostly bees. And then the perennials are a eupatorium and helenium again. Anyway, if growing flowers just for the sake of providing resources for pollinators isn't something that you can really dedicate space to, I know that everyone's got farms everyone's operating on kind of like a tiny footprint in urban spaces, then you can sometimes incorporate something that could be harvested or something that can grow right between your plants. So you're kind of like, this is like the space efficient strategy. And it's just called intercropping, when you plug in some intentionally designed plant between rows of regularly scheduled crops. So lots of people choose alyssum. Sweet alyssum is an intercrop. That's really, really attractive to both parasitoid wasps and to hoverflies. And here's an example of an orchard system where they did blocks of sweet alyssum between apple trees, and that led to really strong suppression of woolly apple aphids. They're kind of the most adorable aphids, but they are like a huge problem in apple systems. Anyway, these are woolly apple aphids, and they found like way fewer of them on the plots where they intercropped sweet alyssum between the rows of trees. And they found way more hoverflies, way more natural enemies. That's like what we call like beneficial insects that eat pests. They found more of those in general in the plots where they put sweet alyssum in between the rows of apple trees. So it's providing this incredible resource to an important pollinator, and also a predator of these aphids on the plants. So those hoverflies are really like doing double duty. They're kind of incredible animals. Anyway, finally, like a really important way to avoid collateral damage to your beneficial insects is to be mindful of, there's like some like lots of farmers try to make a commitment never to use pesticides, but sometimes there's like a moment where you have to pull the trigger or lose your crop. And so choosing things that are going to be relatively less toxic. Even among the organic, this is a list of registered organic products that vary in their toxicity to bees and other pollinators. And so a lot of the stuff that we might perceive as relatively less lethal, like just being registered organic, doesn't necessarily mean that it isn't gonna do some damage if you apply it in a way that will lead to a direct hit by a pollinator. So a way to manage your applications is to choose pest specific chemicals. If you have a caterpillar outbreak, you can choose BT, Bacillus thuringiensis, and that can only kill a caterpillar that eats a leaf. So if a bee comes into contact with that, then it's gonna do them relatively no harm. And if you have to apply some of these like highly toxic broad spectrum materials, then if you avoid applications during bloom, and particularly at dusk, then you'll be more likely to avoid bee activity. And most of these products degrade really quickly, so they won't be persistent on the plants for very long. But if you're interested in figuring out how to co-manage like pest control and pollinator health, then there's like a big resource list again at the Xerces Society. If you just Google I put it in search terms because they've changed the link for this repository a couple times. So I wanted to give you information that'll persist. So if you just Google Xerces agriculture and pesticide, you'll get this page with a big long list of manuals that you can use to kind of like think about how to balance those competing priorities of pest control and pollination. And again, there's an awesome book on farming with native beneficial insects, and also another book on attracting native pollinators that the Xerces Society has published. And all of these are like they're really I'm coming from a big land grant university, but like the Xerces Society does the best job of extension from the perspective of conserving pollinators in agricultural systems, and particularly in urban farm systems. So there's a section of both the farming with native beneficial insects and farming to attract native pollinators. This other book that include specific sections on incorporating habitat in urban spaces. And finally, I'm wrapping up. I wanted to keep it brief for us in case we want to have a conversation about any of the stuff that we've learned today. But another really cool party trick. It's like there's an app that's been like incredibly improved over the last 5 years. It like really freaks me out. I'm gonna be out of a job pretty soon because of Google Lens. But if you use Google Photos to manage your photos on your phone, it automatically comes with that app. So if you see this icon in your Google Photos app, you can just click on it on any photo of any insect that you take. And it's like pretty creepy how precise they've gotten it, matching the pixels in the image with the algorithms based on other images that other people have taken. So it's kind of like a new approach to using an app to identify things, and it's creepy how accurate it is. It's not going to be like you can't use like an app to be like I wouldn't depend on it 100%. Like certainly also check with if you're not totally sure about a confirmed identification, certainly check with an entomologist. And if you tag me on Instagram or upload pictures to the Great Georgia Pollinator Census feed as well, then there are people on there that can kind of help you as you go on that journey if you decide to join us for the Great Pollinator Census. And I hope that you do. It's a really exciting opportunity to join with all of your like-minded friends in celebrating pollinators on the farm. And so they have an Instagram feed explicitly that exists just to help people with identifying things as they're doing the census. And my friend Becky Griffin leads the charge on that. But lots of us like weigh in and just comment on the Instagram feed to kind of confirm identifications for people. And if you're on Instagram, like give me a follow too. My students and I are like always up to really interesting and fun bug stuff that we like to share. But anyway, you've gotten links to the Pollinator Census website numerous times from the Food Well Alliance folks and from me as well. But here it is again. And there's another link here for this, like there's the regular data sheet and the regular portal that they have is pretty useful. But I think that this one, I want to zoom in to see if I can show you what it is. This is like a cheat sheet. This is the one that I use so that I can make sure I distinguish all of them. So a lot of that information that I shared with you about how like the Carpenter bees have shiny bald butts and the bumblebees have hair on their bodies but a spot on their head, and it just gives you you've got the data sheet right here alongside this information that will help you distinguish the kind of like cryptic looking pollinators from each other. Here's a thing that helps you identify wasps. These guys have like a way more constricted waist than any of the bees do, if you can tell the difference between those two. Flies and butterflies, and the whole gambit. Anyway, let me zoom out again. If you they also have a Facebook page if you don't use Instagram. And that is the name of it. It's not too hard to find. And if anyone has questions, I'm happy to take them. And my contact information is on the beginning slide. So if Bobby and the Food Well Alliance people like send this slide deck out to y'all, I should be easy to get a hold of if you have any questions about bees in the city or any other kind of beneficial insect generally. But thanks for letting me join you.